Welcome back, dear students. This is Ramana Sir Physics. Today, I am going to discuss about the laws of motion part 3. So here in part 2, we detailedly discuss about the motion of your bodies in contact and connected by string along with numericals, okay, along with neat diagrams. So we discussed detailedly. So if anybody missed this, okay, so I have given in description part 2 description, so you can go through that, okay, so then only you can understand this topic, okay. So here don't skip this video till end of the class, okay. So why? Because most important topic is there today. So the lift cases and string cases in competitive examination, if you observe, compulsory they are giving this type of questions, lift cases and string cases, okay. So they are asking, okay, along with diagrams, detailed explanation I given. After the explanation, okay, based on these topics, okay, numericals also I'll explain, okay, in this class. So that is why don't skip the class till end of the class. If you, okay, watch this video, you can understand this class very easily and you can solve any type of question, okay. So lift or elevator or string cases you can solve easily, okay. So let's start the class, okay. So our topic is what? Lift cases today, okay. So lift or elevator, okay, and then afterwards string cases we have to discuss. So suppose a person standing in a lift on weighing machine, okay. For example, lift is at rest, so the person weight, okay, it shows to the true weight only, so that is mg. Weight is what? Mg. Mass and weight is different here. Mass means, okay, will denote with the symbol m, okay. Weight means we have to multiply it with g, mg, okay. Weight of the person means what? W equal to mg. Here whenever lift is at rest, okay, so the weighing machine shows, okay, its true weight, okay, its true weight it shows, okay. So that is W equal to mg. So whenever lift is moving upward, so that time, okay, so lift shows, okay, so heavier than his true weight, okay. So you'll observe, you'll feel whenever lift is going up, okay, so you'll feel heavier than your weight, okay. So same like that only, whenever lift is moving downward, so you will feel, okay, lesser than your true weight, okay. So if you observe, if you stand on, okay, so weighing machine, so you can observe your weight also. So that changing weight is called, okay, the difference of weight compared to your true weight, so that weight is called apparent weight. That weight is called what? Apparent weight, okay. So whenever lift is falling freely, for example, so okay, wire is broken, so that falls freely like that, okay, that is like freely falling body. So that time there is no apparent weight, the apparent weight is what? Zero. So your motion is like freely falling body, okay. There is no acceleration, okay. So acceleration is what? So a equal to g we have to take the time, like freely falling body, okay. These all cases detailedly we'll discuss in this class, okay. So first of all, okay, first case you can observe here, okay. So lift is when the lift is at rest, okay. So one person is on lift and the person stood on, okay, weighing machine. So that time what happened? Lift is at rest, lift is at rest. So what happened that time? The true weight of the person is what? Mg acts vertically downward, okay. So weight of the body acts vertically downward. At the same time, so the weighing machine, okay, exerted some force upward, so that is action reaction. The person stood, okay, so the person is standing on weighing machine, so the weight of the person acts vertically downward. At the same time, so the weighing machine exerts some force against that, okay, so his weight, so that is called, okay, So reaction, the person weight is action means against is what? So reaction, action reaction pair. Okay, so this reaction is denoted by the symbol R. So that only we are calling apparent weight. So this R only called what? Apparent weight. So when the lift is at rest, okay, so the time this apparent weight, okay, apparent weight is apparent weight, okay, R is equal to mg true weight. The apparent weight is equal to what? Is true weight, whatever the mg. So here weight and mass is different. Okay, so mass means just will take, okay, m. Okay, so here a person mass is 60 kilograms. Okay, 60 only will take. So weight means what? 60 into 9.8. G value is how much? 9.8. So like that we have to take. Okay, so here the apparent weight is equal to what? The true weight, the person's true weight. Okay, so when the lift is at rest. Why? So here the acceleration of the body is what? Zero in this case. Okay, acceleration is zero and resultant force also zero. Resultant force also zero. Okay, so just his true weight is equal to what? Apparent weight. Why? Because so there is no motion in the lift. Okay, second case, if you observe, so when the lift is moving uniformly upward or downward direction, so it is going upward or downward, whatever. Okay, so what happened? Upward or downward it is going, but uniform speed it is going. Okay, so there is no change in velocity. There is no change in velocity means here also what? Acceleration is zero only. There is no change in velocity, so then acceleration is zero. So in this case also the apparent weight, okay, in this case also the apparent weight, what happens? Apparent weight, okay, R equal to mg only. Why? Because acceleration is zero. So acceleration zero means F equal to ma. The resultant force also what? Zero only. Okay, so in the both the cases accelerations and forces are zeros only. So that is why the apparent weight R is equal to the true weight only. This is when the body is uniform motion. So that is upward or downward, whatever. Okay, so next another case we'll see. Okay, when the lift is moving upward with an acceleration a. So now lift is moving upward, so with some acceleration a. So what happens here? Lift is moving upward, so which direction is more? Upward direction. So means the time what to do? So this R value, okay, so this moving towards the, okay, moving towards the R. Okay, that is why what I am taking R minus mg I'll take. Why? Because mg is downward direction but lift is moving upward direction. So which one is? Okay, so upward direction is there, I'm taking positive. Okay, here mg is downward direction but lift is moving upward, so that is why what I'm taking mg I'll take. Okay, is equal to, is equal to resultant force is equal to what? Resultant force. Okay, here R equal to what? R, okay, minus mg equal to F equal to what? Ma? Ma. F equal to, we know that formula ma. So therefore the apparent weight, okay, so the apparent weight R equal to mg minus mg. I am sending that side, what happened? Plus mg, and this ma as it is mg plus ma. So you can observe here very clear. So apparent weight when the lift is moving upwards, the apparent weight R equal to mg plus ma means the true weight, whatever the true weight is there, plus ma. So adding some quantity means, okay, what happened? The apparent weight is increasing. So that is why we'll feel heavier mass, okay, heavier weight when the lift is moving upward direction. Okay, so R equal to, so m you can take common, m into g plus a, m into g plus a. R equal to what? So m into g plus a you can take here. Okay, so here fraction. Okay, so fraction of apparent weight. Okay, so increasing apparent weight while taking time. So fraction of apparent weight. Okay, fraction of apparent weight, fraction of apparent weight taking time. So what to take here? R minus mg by mg, R minus mg by mg. Okay, so you know that R minus mg is what? Ma. Ma by mg. Gets cancelled. A by g. Okay, A by g percent. A by g percent. So this is the, okay, the last question. How much percent is increased? Okay, so using this formula, A by g percent, okay, will increases. Okay, so this is the, when the lift is moving upward, the person feels heavier than, okay, original weight. Okay, so this is the case. Another case is what? When the lift is moving downward with some acceleration a. Okay, now lift is moving downward, okay, with acceleration what? A. So we can observe, okay, in the diagram. So your lift is moving downward. Okay, lift at rest time, the weight mg is equal to what? The apparent weight r. The apparent weight r. Okay, so when the lift is moving downward, okay, lift is moving downward, so what happened that time? With some acceleration a, so which direction it is moving? So towards the mg direction, downward it is moving. Okay, so that is why mg I am taking first. Okay, mg I am taking first, minus this r is upward is there, but lift is moving downward, so that is why against that, okay, it is moving, that is why minus r I am taking. Why? Because mg is downward, positive I taken, but r upward is there, then lift is moving downward, so that is why minus r I taken. And resultant force F as it is I am taking. Resultant force is what? F. Now F value you can substitute with what acceleration it is moving? Ma acceleration it is moving. Okay, so F equal to what? Ma. Now, okay, this r send that side, what happened? It becomes positive. Okay, so that time what happened? That time r equal to mg minus ma. Now it is very clear, whatever the true weight minus some force is there, okay, ma. Okay, from true weight we are, okay, subtracting something, means what happens? Weight, what happens? Apparent weight, what happens? Decreases. So that is why when the lift is moving downward, we feel lesser than our original weight. Okay, so why? Because apparent weight r equal to r mg minus ma. So if you take r equal to m, if you take common, so what? G minus a, g minus a. Okay, so g minus a. So in the previous case, when the lift is going upward, so r equal to, okay, what? M into g plus a. Here r equal to m into g minus a. Here we'll feel, okay, heavier than original weight. Here we'll feel, okay, so lesser than original weight. Here percentage, okay, the fraction, what we can take? Fraction of apparent weight, mg minus r by mg. Okay, so mg minus r by mg. So here mg minus r is what? Ma. So here ma by mg, gets cancelled, what we can take here? A by g. So here the percentage, what happened? Here decreases. The percentage, what happened? Here decreases. Okay, here increases, then decreasing. Next, the last case, okay, we can observe. So for example, okay, if the lift falls freely under gravity, okay, under gravity g. Okay, so for example, so unfortunately the lift wire is broken, so that time how will feel? Okay, so the lift falls like freely falling body, so that time the apparent weight of the person is 0. Okay, so it will not show any weight, so it shows 0. How? So we'll see. Okay, so lift is moving downward or upward, so lift is falling falling means what? Downward time, which case? Apparent weight case is what? So when the lift is moving downward, okay, so the apparent weight formula is what? R equal to m into g minus a, m into g minus a. So we know that, okay, so freely falling body acceleration what will take? Okay, a equal to g will take, already given here, a equal to g will take. Substitute here r equal to, okay, that equal to m into g minus g. G minus g is what? 0. 0 into something is what? Okay, m into 0, that is 0. So therefore the apparent weight is what? 0. The apparent weight is what? 0. So it does not show any apparent weight. Okay, so it shows 0. Okay, so these are the lift or elevator cases. Okay, lift or elevator cases. Okay, after a string, okay, a person is hanged from a string, okay, with help of string. The string is fixed at roof, okay, at rigid support. String is, okay, so fixed to a rigid support. I'm showing here, you can observe, for example, here one string is there, okay, so with help of the string, so some load is attached, so the string is fixed to a rigid support. String is fixed to a rigid support. So what happened? The body weight is how much? Mg. Body weight is mg. So that time what happened? This mg acts vertically downward. So mg acts vertically downward, so that we can take what? Mg. Mass of the body here take, okay, mass of the body m, and weight of the body acts vertically downward, mg. At the same time, okay, so here apparent weight how we taken? The exerted reaction force. Here the, instead of reaction we have to take tension in the string, so that acts upward. So only just instead of r we have to replace by t, everything is same only. Okay, so tension in the string, t we have to take, all same cases. Okay, so at rest, okay, what happened? So the tension is balanced by mg. Okay, so at, okay, uniform speed it is moving, so 0. Same cases, just we have to replace, instead of r with t we have to replace. So based on these cases, okay, now we'll discuss, okay, most important topics. Okay, so once you check the formulas, I'll start the numericals. You can observe question on screen. Okay, the apparent weight of a man inside a lift moving up with certain acceleration is 900 newtons. When the lift is coming down with the same acceleration, apparent weight found to be 300 newtons. The mass of the man is, within the bracket, acceleration due to gravity g value also given, that is 10 meter per second square also given. It is moving upward, r equal to, so what is the formula? Mg plus mar, m of g plus a, so you can take, okay, apparent weight r equal to mg plus ma. So the time r value is given, how much given? R value is, okay, 900 newtons given. So 900 newtons, 900 newtons I am taking, is equal to mg plus ma. Okay, so next, lift is moving downward, so that time r value is how much? Lift is moving downward, r equal to mg plus ma is the formula, mg minus ma. Okay, so when the lift is moving downward, r equal to mg minus ma. So the time, so the r value is given, how much given? 300 newtons given. 300 is equal to mg minus ma. Okay, 300, so mg minus ma. So these two equations, if you say this is equation 1, this is say equation 2, okay, so solve these equations. Okay, so what happens here? Solving time, so I'm adding these two equations, equation 1 plus equation 2. I'm adding these two equations. So what happens here? I'll write the equations. Okay, how much here? R value, equation 1, how much? 900 is equal to how much? 900 equal to mg plus ma, and equation 2 is how much? 300 is equal to mg minus ma. Here I am adding, so here what happened? Plus ma minus ma gets cancelled. Okay, so 900 plus 300 how much? 1200 is equal to mg plus mg, 2 mg. So here 2 1 ja, 2 6 ja, and these two zeros as it is. So mg equal to what? Therefore mg equal to 600 newtons. So we need only m value, mass of the man they are asking. So m equal to what? 600 by g. Here g is given 10 given. Okay, 10. So 10. Okay, 1 0 and this 0 cancel. Therefore mass is how much? 60 kilograms. Mass is how much? 60 kilograms. So the which option is correct in this? Okay, mass m is 60 now. So second option is correct option. Next question you can check on screen. A 60 kg man is inside a lift which is moving up with an acceleration of 2.545 meters per second square. The apparent percent change in his weight is. So in this apparent weight, apparent percentage they are asking. Okay, so apparent weight in percentage they are asking. So just now we discussed, okay, when the lift is moving upward, so the apparent weight, okay, so our fraction in percentage how much? A by g percent. Okay, A by g percent. So A by g percent means A by g into 100 I am taking, okay, in percentage. So into 100 I taken. Okay, A is given how much? Given 2.45 meter per second square, and here mass also given but not required mass here. Okay, A by g value not given, so that is why 9.8 only I am taking, 9.8 meter per second square. Okay, the previous problem g value within bracket they given 10 meter per second square, so that time we taken 10 meter per second square only, but in this case not given, we have to take 9.8 meter per second square only. Okay, into 100. Okay, so here 2.45. So what I'm doing, one decimal purpose here, one decimal I'm cancelling, 24.5. Okay, so 24.5. So that I'm this one more zero purpose, what I'll do, 245 I'll write, 245 by 98 into 10 is there. So into 10 means what? So here directly I'm multiplying here, so 0. Okay, so 2450 divided by 98. Okay, so what happens exactly? So how much we'll get? 25% we'll get. Okay, 25% will get. So therefore in the option, okay, so the apparent weight how much is there? Percentage 25%. So second option is correct option. Okay, next one you can continue. When an empty lift is moving down with an acceleration of g by 4 meter per second square, the tension in the cable is 900 newtons. When the lift is moving up with an acceleration g by 3 meter per second square, the tension in the cable is. In this question what they are saying, empty lift moving downward, so that time, okay, acceleration they given clearly g by 4 acceleration, so that time tension in the cable is given 9000 newtons. Then when the lift is moving upward with acceleration g by 3, okay, what will be the tension in the cable they are asking. Okay, so according to the question, so we'll solve detailedly. So when, okay, lift is moving downward, so that time, okay, so apparent formula we know that already, R equal to m into g minus a, g minus a. With what acceleration it is moving downward, so that time how much the tension in the cable. Here I said instead of, okay, R we can take T, okay, for cable cases purpose. Okay, so 9000 newtons given. M into g minus a is how much given? So with g by 4. Okay, so with g by 4, okay, with acceleration, what acceleration it is moving? G by 4 acceleration, so that is a g by 4 only I taken. Here 9000 is equal to, okay, m into Here 4 is the LCM. 4g minus g, how much? 3g by 4. 3g by 4. Here 3 1 ja, okay, 9000. 3 1 ja 3, 3 ja, and 3 zeros as it is. And this 4 I am multiplying here. 4 3 ja 12. 12,000 is equal to what? Mg. So this is say equation 1. Another case we'll see. When the lift is moving upwards, okay, so the time apparent weight in the cable, okay, the tension in the cable they are asking, okay, that is nothing but apparent weight. So the time acceleration, with what acceleration it is moving upward? So g by 3 acceleration. So the time formula is what? When the lift is moving upward, so the time formula is what? R equal to m into g plus a. M into g plus a. With what acceleration it is moving? G by 3. R equal to m into g plus g by 3. Okay, now here LCM is what? 3. 3g plus g, 4g. M into 4g by 3. Here 4 I am writing outside. Okay, 4 by 3 I am writing outside. Remaining is what? Mg. Okay, this Mg value, so just now we got in equation 1. So substitute R equal to 4 by 3 into Mg is how much? 1200. Okay, so here 3 1 ja, 3 4 ja 12. These 3 zeros as it is. Now 4 4 ja 16, and these 3 zeros as it is. Therefore 16,000 newtons. When the lift is moving upward, the tension in the string is how much? 16,000 newtons. Which option is correct? The first option only correct. Next problem you can check on screen. A fireman wants to slide down a rope. The braking load for the rope is 3 by 4th weight of the man. Okay. With the minimum acceleration should the fireman slide down? Acceleration due to gravity is small g. So in this case what they are saying, a fireman wants to slide down with help of the rope. Here the rope, okay, braking load is equal to the given 3 by 4th of mg weight, its weight. Okay, so to what minimum acceleration should he require to slide down, they are asking. So the time will take. So the braking stress, okay, braking load, that is nothing but tension, what they are saying? 3 by 4th of mg they are saying. Okay, how much they are saying? 3 by 4th of mg they are saying. Okay, so when the lift is moving downward, so the time what will be the case? Okay, here the tension, okay, in the string case, so what we can take? M of t equal to m of g minus a, you can take m of g minus a, you can take, is equal to what? 3 by 4th of mg. 3 by 4th of mg. Here m gets cancelled. Okay, g minus a equal to what? 3 by 4th of g. Here acceleration they are asking. Acceleration a equal to what? So g minus 3 by 4g. Okay, here 4 is the LCM. So what happened that time? 4g minus 3g. Okay, 4g minus 3g by g, okay, by 4. Okay, so therefore acceleration a equal to how much? So g by 4. Okay, meter per second square. Acceleration units are meter per second square. So therefore which option is correct? The second option is correct. Next question you can observe on screen. A man in a lift feels an apparent weight W when the lift is moving up with a uniform acceleration of 1 by third, okay, 1/3 of the acceleration due to gravity. If the same man were in the same lift, now moving down with a uniform acceleration, so that is, okay, 1 by 2 of the acceleration due to gravity, then his apparent weight is, okay, so then his apparent weight. Okay, so here when the lift is moving downwards, okay, so the time his apparent weight is given with what acceleration? So with, okay, g by 3 acceleration is moving. with the g by 3, one third of the acceleration due to gravity. So next the time apparent weight is how much? W only. So when the lift is downward with 1 second of acceleration due to gravity means g by 2. So that time what will be the apparent weight when the lift is moving downward, they are asking. So we'll see. So when lift is moving upward, okay, so that time apparent weight formula, so R is equal to what will be the formula? Lift is moving upward, so m of g plus a, but that person is moving with acceleration how much? One third of acceleration due to gravity. This a value how much given? One third of acceleration due to gravity, that is nothing but g by 3. Okay, so when the R equal to how much? So m into, here 3 is LCM, 3g plus g, 4g by 3, 4g by 3. Okay, so that equal to, we can take how much? 4 by 3 mg, 4 by 3 mg we can take. This is say equation 1 you say. Next lift is moving, okay, downward. Next case is what? Lift is moving downward, so that time apparent, okay, so formula is what? Apparent weight formula m of g minus a, but lift is, okay, moving down with acceleration how much? Half of the acceleration due to gravity, that is g by 2. So here you can take R equal to m into, so 2 is the LCM, 2g minus g, that is g by 2. Okay, so that equal to mg by 2. Okay, that is say equation 2. So this is say, okay, second case R dash you take. Okay, they're asking. So second case what will be the, okay, so compared to the first case apparent weight they are asking. Equation 2 divided by equation 1. So 2 equation is what? R dash by R. Equation 1 left hand side is what? Okay, left hand side by left hand side. Equation 2 divided by 1 is equal to equation 2 right hand side by equation 1 right hand side. So right hand side is what? Mg by 2 divided by, here 4 by 3 mg. Okay, so here mg gets cancelled. Okay, so this 3 goes to numerator. What happened? 3 goes to numerator, and this 4 to the 8. So therefore, okay, so R equal to what we can take? R equal to, so R equal to what we can take? The apparent weight while moving downward, so 3R by 8. So here you can observe the apparent weight, okay, they taken W, they given what? W they given, so that is why, so we can take here W, and this one you can take W dash. Okay, so that time what we'll get? W dash equal to 3W by 8. So which option is correct? It is very clear, first option is correct. If you understand these cases, okay, so please like this video and share to your friends, so these topics are very helpful to your friends also. Okay, and don't forget to, okay, subscribe this channel. Okay, and part 4 also there in laws of motion. So in that most important and easy topics are there. So what are the easy topics that related to the motion topics are there, so we'll discuss. Okay, thank you for watching this video.